So now we're going to go through the second case of the binomial expansion. So we said that all brackets must be of the form of 1 plus x to the power of n. Now notice that 4 plus x to the power of a half isn't in that form. So we coerce it or force it to be in that form. So what we do, we open a square bracket. We take a factor of 4 out. And we could write that as 1 plus x over 4, which is an equivalent expression, all raised to the power of a half. Then from the laws of indices, we can say that's the same thing as 4 to the power of a half times 1 plus x to the power of a half, x over 4 to the power of a half, excuse me. Then that gives me the following: 2 times 1 plus x over 4 raised to the power of a half. So what we're going to do, we could write that as 2, now open brackets, now we need the binomial formula here. So it's going to be 1 plus nx, as we've shown in previous videos. So it's going to be a half times x over 4 plus a half times minus a half times x over 4 squared divided by 2 factorial. Let's do the last term we're going to do, which is a half times minus a half times half minus 2 over 3 factorial times x over 4 all cubed plus other terms. Then what that simplifies down to is the following. So we end up with 2 times 1. You can simplify these coefficients on your calculator. So minus x squared over 128 plus x cubed over 1024 plus other terms in the series. Multiplying it all by 2, we get 2 plus x over 4 minus x squared over 64 plus x cubed over 512 plus other terms. So again, like in previous videos, you want to find what the expansion is valid for. So don't forget it's x over 4. So we say mod x over 4 is less than 1. We could write that as x, or mod x times both sides by 4 is less than 4. So in full form, we can say x is greater than minus 4, but less than 4. Here's a question for you to try. You can pause the video, and when you're done, I will go through my work solution. Okay, welcome back. So we're going to write this, first of all, in the correct form. So we could write that, take 2 out as a common factor. And what we can do, if we take 2 out as a common factor, we're going to get 1 plus 3x over 2. And now don't forget, all of this is raised to the power of minus 2. So we get 2 to the power of minus 2 times 1 plus 3x over 2, all raised to the power of minus 2. So we're going to get a quarter times 1 plus 3x over 2 raised to the power of minus 2. So now we have to use the binomial expansion. So put a quarter on the outside. That's our constant term, if you like. And then now we're going to use the binomial expansion formula. So plus minus 2 times, in our case, x is 3x over 2, as I've shown in previous videos, and then we just do the same thing here. Minus 2 minus 3 times 3x over 2 squared divided by 2 factorial. We do one more term, and that will give me minus 2 minus 3 minus 4 divided by 3 factorial times 3x over 2 all cubed plus other terms, and then what we end up with now is a quarter, and then we have, simplifying this on our calculator, 1 minus 3x plus 27 x squared over 4 minus 27 x cubed over 2 plus other terms. Multiplying it all by a quarter, we end up with the following: a quarter minus 3/4 times x plus 27x squared over 6 minus 27 over 8 x cubed plus other terms. Now, if you wanted to find for what values the series is valid for, or the expansion is valid for, we would do the following. We would take mod 3x over 2 is less than 1. So we can do 1 divided by 3 over 2. So mod x is strictly less than 2/3. So in full form, we could write that as x is strictly greater than minus 2/3, but less than 2/3.